Hey guys, since we've been doing these weekly computation practice, adding, subtracting, multiplying, dividing, fractions, and decimals, I thought I'd make a video, just a practice one for you to work alongside me and get some extra practice. I got some Topo Chico today for my bubbly water. I'm going to skip the chit chat. We're going to do 8 problems. Just computations. Computations are like calculations. Quick, boom, let's get the right answer. It's not super complicated in a word problem, but I just want you guys to be fluent. So why don't you get out a piece of paper, pause this video, and work alongside me. If you feel comfortable with a problem, you can work ahead. Pause the video, work ahead. If you feel like this is one I don't know how to do, then watch, pause, and follow along. Rewind if you need to. We'll see how long this video takes. I'm really not going to spend too much time talking. So, all right, Houston, we've got a problem. Gamer life, sorry. The denominators are different, and we cannot just subtract like, oh, that's 7 12s. No, 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 no. We need them to be common denominators, preferably the least common multiple to make us have a number that works. So yes, I could change these to be 30ths. That is a common multiple, but the least common multiple here is 15ths. So I can just rewrite this as some 15ths. 1/3, do you know how many 15ths that is? You just multiply the bottom times 5, multiply the top times 5, and you would know that 1/3 is the same as 5/15. So now we have 8/15 minus 5/15, and we can just subtract straight across. Now, of the numerator, we get 3/15. Cool. Next problem, right? What do we remember about fractions? When we add or subtract, we should always be looking to simplify. That's why the ... imposter rip off the mustache. 3 and 15 share a common factor. The greatest common factor they have is 3. So I can divide both of these by 3, and I would know that that is the same as 1/5. 8/15 minus 1/3 is 1/5. Good practice. That's how you subtract fractions with common denominators. All right, woo, where do we go? Now let's multiply. Multiplying fractions, we can just go straight across. And you might think, oh, that's easy. 2 times 5, that's 10. 15 times 8, how do I do that? All right, well, I can do this a couple ways. I could double, double, double. I could rewrite that as 30 times 4. But we can double, double, double it. 15 doubled. 15 plus 15 is 30. 30 plus 30, or quadrupling 15, is 60. 60 plus 60 is 120. Would you leave it like that? No. You know that we can simplify both of these by dividing them by 10, or taking off a place value, and you would get 1/12. But we learned another way. The kids down in Miss Gray's cohort, they call it the number jiggle. I don't say that. I would say canceling out common factors. So we're basically, what you're doing here is you're multiplying the top times 5 and then multiplying the bottom by a multiple of 5. That's kind of like double doing the work, and you're always going to have to simplify. It's easier to cross off common factors. Like, instead of multiplying times 5, hey, these are both multiples of 5. So let's divide the top and the bottom by 5 here. And we would have that is 1 5, and this is 3 5s. And look here. Here's a multiple of 2. So let's divide them by 2. Boom. And we have 1 times 1 over 3 times 4. And what do you see? That is 1/12. Something Mina likes to talk about is that with the commutative property, when we did this in class, she really liked this. With the commutative property, we could rewrite it switching the order, right? And that is, what? That was a 5. 5/15 times 2/8. All of these are equal. 2 15 times 5/8 is the same as 2 times 5 divided by 15 times 8. I can switch the order, right? 5 times 2 over 15 times 8. And then we just have 5/15 times 2/8. And that is 1/3 times 1/4. If you want me to do one of these like again after watching this video, ask me, hey, can you go over multiplying proper fractions? These are proper fractions we're multiplying, just straight across. It's 10/120ths, but simplified it is 1/12. Cool. All right. Now we have multiplying mixed numbers. These are mixed numbers because they're mixed, whole numbers and fractions. Now, we talked about FOIL before was one way to do it with 4 partial products. But the simplest way is to just make it improper. This is the fast way if you're trying to just be fluent. And we could do another way after or in another video. So 5 and 1/3. Well, if I have 5 wholes of third, one whole is 3/3. 3/3 times 5 is 15. 5 times 3 is 15 plus this extra 1 goes to 16/3. Here I have 4 times 2. 4 wholes of halves is 8 plus the 1 more goes to 9 halves. So I just rewrote this 5 1/3 as 16/3 times 9 halves. And then we'll just go through by crossing off common factors. Do you see anything? We could multiply straight across. 16 times 9 over 3 times 2. Let's look up. This is going to be satisfying. I see multiples of 2. Are you doing this on paper along with me? Please pause it if you're not. Okay. Boom. These are both multiples of 2. So I can divide this by 2 to get 8. Divide this by 2 to get 1. Here I get multiples of 3. Divide this by 3, I get 1. Divide this by 3. Whoa. So overall, it's going to be 8 times 3, and that equals 24 wholes. That's awesome. That kind of makes sense if we were to multiply or estimate 5 times 4. 5 times 4 is 20. We have a half of 5 is 2.5. I'm actually going to FOIL. So I think I have time. This is making the video longer, but I wanted to show you another way how we did it. Okay, 5 1/3 times 4 1/2. Let's bring it down. All right, FOIL. We're going to have 4 partial products. First, outer, inner, last. Let's do first. The first 2 factors, 5 times 4. 5 times 4 is 20. The outer numbers, like the outside, do like this. 5 times 1/2. 5 times 1/2 is 1/2, 1/2, 1/2, 1/2, 1/2. It helps you do it like this. 5 halves, or 2 1/2. First, outer, inner. This is the inner fractions. This is 1/3 of 4, or 4 times 1/3. 1/3, 1/3, 1/3, 1/3 is 4/3, or 1 1/3. And L stands for last. You'll use this in algebra. Laster? What am I doing? Okay. It's been a long day. The last are just the fractions. 1/3 times 1/2, or a half of a third. Half of a third, or 1/3 times 1/2 is 1/6. Let's add these up. Houston, we got the problem. They got to be the same denominators. I'm going to just change them to the same denominators. So rewrite the LCM is 6, right? I can change 2 and 3 and 6 all to be 6. So instead of 2 and 1/2, I'm going to write 2 and 3/6. This is 3/6. Yes? Okay. Plus 1, and instead of 1/3, I could write it as 2/6. And then I just have 1/6 at the very end. Wow, this is cool. Let's add the fractions. 3/6 plus 2/6 plus 1/6. 3/6 plus 2/6 plus 1/6 is 6/6. 20 plus 2 plus 1 is 23, and 6/6, or 24. Wow, how satisfying. Beautiful. So that is how you FOIL it. You are not required to know how to FOIL it, but it helps you see the pieces that come together to make it here, just like our estimate. Doing improper fractions is fast, but you don't understand the math as much, I would say. So I would love for you to be able to do both, but at least be able to do the improper one on your own. All right, moving on. Here we have 5 divided by 1/3. Whenever I see division, I think, how many are in? That's kind of my sentence stem. And it gets harder with fractions. So if it was, 20 divided by 4, how many 4s are in 20? Oh, I just divide that. 20 divided by 4. Here with this one, I would really love you to be able to rewrite this in a sentence. When you do these problems, you get like bonus cool points, bony points. How many 1/3, that's our divisor here. You can write this down too. How many 1/3 are in our total? Are in 5. And that's the dividend. You don't need to write it down, but dividend. How many 1/3 are in 5 wholes? Okay, so if I had 5 wholes, 1, 2, 3, 4, 5. And I chop them into thirds. That's a picture for it. Here I have 5 whole divided into thirds. I have 5 pies, dividing them into thirds. How many pieces will I have? Well, there's 3/3 here, 3/3 here, 3/3 here, 3/3 here, 3/3 here. So 3, 3, 3, 3, 3 is 15 pieces. How many thirds are in 15? How many thirds are in 5? 15. Boom, period. End of sentence. You also will know keep, change, flip, which is one way to see this. Keep the first number. Change, when we're dividing, change to the opposite operation, and then flip to the reciprocal. That's one way to remember it. Do you know why? Kind of like one way to think about it is when we divide, well, fractions are kind of like an example of division. Fractions are tied with division. If you're dividing with division, it's kind of like doing the opposite, a double negative almost. I would love to explore more with why this works. You doing keep, change, flip is not becoming the master of fractions. I think understanding what it means and being able to draw a picture helps you understand why. So I'm glad that you know, oh, we can keep, change, flip, get the answer. But math is not always about getting the answer, but understanding why that works. All right. halfway done. Let's zoom in. Now this one's kind of cool. What was the sentence? It gets getting harder. What was the sentence we like to do for division? How many are in Okay, so this one would be how many 2/3 are in 10/12. So I'm going to draw this. Okay, let's do it like this. You could draw this too. I'm going to draw 12ths this way. No. I'm going to do it like this. Let's see. It's that last line again. All right, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 12s. Let's shade in 10 12s. Okay, 10 12s are right here. How many 2/3 are in here? Now check this out. 2/3. Well, I see 1, 2, 3 columns. Here's 1/3, 2/3. How many 2/3 are in 10 12s? I know there's one, and then like a piece of it. So how much is this? What fraction would it be? So we're going to go to keep, change, flip. Keep your first number, 10 12ths. Change division to be multiplication, and flip to the reciprocal. So instead of 2/3, it's going to be 3/2. Let's multiply it straight across, and we get 30 over 24. And what does that equal? 1, what's left? I'd have some extra. 6/24. Dot, dot, dot. And what does that equal? 1 and 1/4. 10. Oh, 1, 2, 3, 4, 5, 6, 7, 8. Were any of you like, Mr. Dix, that's not 10 12s? Messed up. This is 10 12s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 12s. And here's there's 1 2/3 in it. What do we have extra? We have this amount extra, 2 pieces left. And you're like, how does that equal a fourth? Well, now the new whole is 2/3. So we're dividing by how many 2/3. So what does this represent? These two represent out of the 2/3. Let me show you. Oh, could I? Oh, I wish I could bring this. Maybe I can. Oh. All right, look. This is the extra part. This was here it was 6/24. Now look, how much is that? How much is that in 2/3? In regards to 2/3, this was 2/3 of the whole. I have 1, 2, 3, 4 of these, and that's what's left over. 1/4 of the 2/3 is left. How much is this part right here? This part we didn't shade in regards to our 2/3. It is not half of the 2/3. It's actually 1, 2, 3, 4, 1/4 of it. Now that's really hard to see. I'm excited for you to do more of that in 6th grade of seeing it visually, and we'll do it this year too. So do not just keep, change, flip, but if you're curious of like, how is it 1 1/4? How is 1 1/4 of 2/3 in 10/12? Well, I know that. Okay, anyway, the video is getting long, right? All right, let's do some subtraction. If you're on fraction, stop here. Why don't you just do some decimals with me really quick? Just double check. I'll show you. This is one problem. Write it down. Pause the video. This is one. These are other two problems for you to practice. All right, but we're cruising. Look at this. I could be chilling, watching TV. I'm hanging out with you guys, drinking my topo. I hope this is helpful. Send me an email if it was helpful, because this is my personal time I'm giving up for y'all. All right, 20.04 minus 6.37. Now, this is a little tricky. It's not the normal 9999. There's going to be something extra here. So 4, remember there's regrouping. 4 minus 7, no, we don't have enough. Oh, I could change the tenths. No, I could change here. So this is going to be cool. Oh, but I need some in the tenths place. So that's going to be 9. Now I give here. We good? No. I need some over here. Cross off 4 hundredths. Give it 10 more hundredths, so that becomes 14 hundredths. And then we just subtract. 14 minus 7, 7. 9 minus 3 is 6. 9 minus 6 is 3. Bang. How could you check your work? By adding it up again. 13.67 plus 6.37. Just super quick, we add it. 14, I know that. That's 10. I know that. That's 10. I know that. Bang. Got it. All right. Simple. Subtraction's good practice for us. Now let's do some multiplying. Mr. Dick says you should. Do you know how to fill that sentence? Mr. Dick says you should estimate first. Let's just estimate. 37 times 4.5. Let's just say it's about 5. Let's just say it's 40. I'm rounding up, so I think it's about 40 times 5, 200. I'll say less than 200 because I rounded up and I rounded this up. Both numbers are actually lower. So I think it's a little less than 200. So if I get something like 157, 187, cool. If I get an answer like 18, my decimal's off. How many 3s are in 13? Like 4? Okay, now we're just going to get cruising. When we multiply these decimals, we don't have to line them up. We don't have to add up extra digits and stuff. I'm going to honestly just keep it over here. You putting an extra 0, then you'll just start 0, 0, 0. Don't just leave it. Okay. All right. And we're going to cruise. You want to do this with me? You want to race me? Give you a head start. You got a piece of paper? This is not just watch math time. This is let's do it. Let's do some math. Okay. Boom, boom, boom. Boom, boom, boom. Okay. All right. And then I will strike through these so I don't get confused. Now, I came in like a wrecking ball. Is that what Mr. Flores did? I don't know. This 4 is a bigger place value. So it's not has the same value as here. We need to put a 0. 4 times 4, 16. Are you working this with me or on your own? 28. 12 plus 2, 14. Make sure your digits are all lined up. Bada bing, bada boom. 4, 8, 3, 10, 7, 1. Okay. Let's see. Survey says 37.04 times 4.6. Ew. Yep. Well, where does that decimal place go? My estimate was about 200. Does that make sense? No. Does 1,700? No. It must be here. 170. Cool. Good job. All right. Now let's do this division. So I have 13.2. I'm going to divide it by 3.2. Now, we haven't really done this, a lot of this. In Khan Academy, you have. But if I'm dividing by a decimal, I would rather divide by a whole number. So I'm going to increase my place value by moving up each one of these digits. So I can move this up by moving the decimal point back. So now I move this back one and this back one. So this, yeah, let me just redo it underneath. Instead of 13.2 divided by 3.2, I am going to have 132 divided by 32. And it will get me the same answer. I might need some decimal points. Okay, think of your 32 facts. And that's when you just round and estimate. How many 30s are in 132? I'm going to guess 6. No, 4. So let's try it over here. 8, 12, right? Yeah, it's 4. How many 32s are in 1, 0, 0? There's no 32s in 13. So then I'm going to go to how many 32s are in 132? I know it is 4. And I get 128. Subtract. You know what we can do? Put a 0. I'm going to maybe put 3. Let's just get crazy. We'll see what goes down. All right. Boom, 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 boom. Ooh, I have 4 out of 32. My fraction, kiddos, do you know what that is? Simplified down to? If you don't know, let's find out. I'll write it up here. So the remainder is 4 out of 32. Do you know what that equals? Okay, moving on. Bring down that 0. How many 32s are in 41? Bring down that 32. 1 times 32 is 32. Subtract it. Boom, 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 boom. Bring down the 0. Now we have 80. How many thirds are in 80? 2. 2 times 32 is 64. Subtract it one more time, then we're done. This minus that is 16. Bring down the 0. All right. How many 32s are in 160? Pretty sure it's 5. Bingo, what's his name? Oh. We are done. I told you my estimate was, there's about 4. Well, the answer is 4.125. Do you know what 4.125 is? I mean, especially 125 as a decimal, it is equal to 1/8. Ha ha ha. Okay, that's it. We went through this. We subtracted, added fractions. We multiplied proper fractions, multiplied mixed numbers, divided a whole number by a unit fraction, divided a fraction by a fraction, subtracted decimals, multiplied decimals, divided by a decimal. Send me an email which thing you're still stuck on or if that was super helpful. That video was long. I know it was. I'm about to just stop. It's good to be back with you and do some math. I hope that was helpful. Bye, y'all.